As a solo developer or small startup, you do spend time thinking about what you're building before you start building. Vibe coding changed that completely. Even as a solo developer, I'm able to build something in an hour, but I'm often left thinking, hey, what did I build? What were some of the decisions I made? Because you move so fast, get a response, you're like, well, I don't quite like that. I'd like it to do this instead. And the back and forth with the agent sometimes is basically a stream of consciousness. So that's the core problem space we were looking to solve with Kiro. We're not looking to just build yet another agentic editor. And spec-driven development is the approach we think will be the way everyone develops with AI going forward.
What are some of the key learnings that you have took from this journey of learning about specifications?
Specifications are combinations, artifacts in the Kiro product, but high level, they're about behavior. And the learning is they need to be composable documents with really functional business use cases, as well as code, pseudocode people can put in there, technical diagrams, behaviors around error handling, behaviors around properties.
How do you see people in future wanting to use specifications?
Okay, so that's a very deep question.
Hello and welcome to another episode of the AI Native Dev. My name's Simon Maple and I'm your host for today. And today's going to be a fun episode. We're going to be talking very much about spec-driven development, but also looking at and seeing a new pretty cool tool actually on the market, which has been very recent, called Kiro. And Kiro is, well, I'll let the folks here introduce it, but it's a spec-driven way of being able to build software in your IDE, which is very, very interesting. And we're going to go into a few pieces talking about the philosophy of spec-driven development, show a demo of Kiro working, and then talk a little bit about the journey that the folks had at AWS in order to get to where we are today. So let me introduce Nikhil Swaminathan and Richard Threlkeld. Hey folks, how are you doing?
Hey Simon, doing great.
Doing good. Thanks for having us on.
So let's jump into what your roles are at Kiro. Nikhil, why don't we start with yourself?
Sure. I'm the product lead for Kiro, so I've been now on the Kiro team for the past 6 months or so, though it feels like I've been here for years at this point. And my job is to one, help build out what features we need to build, and two, work with the team on making sure we're doing the right thing.
Awesome. And Kiro is around a year and a half. Is that fair to say? A year and a half in build time?
Yeah, close to that. I think, let's see, it's July, about 13 months actually. Yeah, so I'm Richard. I'm an engineer on the Kiro team. I've been, as Nikhil kind of alluded to, I think either the first or the second engineer that's on the team when we started it. And so I've been involved in all phases of Kiro development, but specifically, no pun intended, I actually focused the majority of my time on specs, including the original research projects with a lot of the Amazon science teams.
Amazing. So looking forward to getting deeper into that. We've said Kiro a few times. My introduction probably didn't do it justice. Why don't we jump into what is Kiro? Nikhil, why don't you walk us through, give us the definition of what problem Kiro is trying to solve.
The elevator pitch, yeah. So Kiro is an agentic IDE that helps you do your best work. That's our tagline. So let me unpack that a little bit because that's a little vague. So unless you've been living under a rock the last year and a half, agentic IDEs have become really popular. What are they? The agentic IDEs allow users to use natural language. So developers use natural language to interact with an agent to generate code for an application. And what that enabled is, what used to take us like days or sometimes even weeks to build a feature or prototype, has allowed us to build this almost in hours now. And what agentic IDEs really popularized was the term that we all are very familiar with now, called vibe coding, that really allows you to use natural language and chat with an agent to help you generate code for your application. I think of vibe coding as almost like ChatGPT for coders, right? You go back and forth with an agent to build features out. And while vibe coding has been great to help people get up and running really quick, the process does completely short circuit traditional software development lifecycle best practices and how teams of software engineers often work on a day-to-day basis, right? Working on a team here at Amazon, and prior to Amazon, I ran a startup, so I've actually experienced both worlds. When building a feature, you often spend days, or if not weeks sometimes, detailing out requirements and designs before you actually start coding. And even as a solo developer or small startup, you are definitely moving faster because there's less coordination. But you do spend time thinking about what you're building before you start building. Vibe coding kind of changed that completely, right? Even as a solo developer, I'm able to build something in an hour. But after one session of vibe coding, I'm often left kind of thinking, hey, what did I build? What were some of the decisions I made? Because you move so fast, right? Like you get a response, you're like, well, I don't quite like that. I'd like it to do this instead. And the back and forth with the agent sometimes is basically a stream of consciousness, and it takes you a minute for you to kind of reflect and think about, hey, what did I actually get done? So that's kind of the core problem space we were looking to solve with Kiro. We're not looking to just build yet another agentic editor. We really think that the way you work with AI is going to change, and spec-driven development is the approach we think will be the way everyone develops with AI going forward.
Yeah, really interesting, and I love the kind of the way you talk about how very often you sometimes make decisions, but that decision's then in your mind versus, you prompt it very, very quickly, but you're actually not capturing that. And while a lot of it is represented as code when you're vibe coding, it's hard to then disseminate afterwards, well, what is the decision and what is just an implementation? And if you was to almost like think, in future, if someone else was to come in and look at your code, you could somewhat guess what is decision, what is meant to be, and what is an assumption, and what is an LLM choice. But it's not clear. It's a mixed kind of reality in code. So that's what I love about specs, the way it kind of pulls that out and allows individuals who read that spec to effectively understand what the individual or team that was developing that is really adding in.
Yeah, no, I was just saying one of the analogies I use when talking with people on the team is that it's vibe coding is almost like a sometimes a Slack thread where there's like a stream of consciousness. There's often, when you work with teams, there's really long Slack threads, right, which have like 50, 60 messages because they're, complicated topics that you're discussing. But then a lot of the decision log is captured in that thread versus a document, where you're like, okay, here's a document, let's review that document, make sure we're aligned on that document before we actually go implement it.
Yeah, really interesting. And yeah, and also like a Slack message is a point in time message, and it is relevant at that point based on the context that has already passed and not on the context that has gone ahead of that. So it is relevant and true at that point. Whereas a spec is the spec. It's like when you see the spec, that is the final outcome. Very similar to, I guess, when I'm prompting in a vibe coding environment, my prompt is relative to the code as it was, the code as it is after the prompt, and it really connects those two points in time. At any point afterwards, the prompts that I use may not make any sense because it's only referencing the point in time just before I sent that. So yeah, very aligned on that. We've mentioned specs a few times. I'd love to go a little bit deeper. Richard, bring you in here. What do we mean by a specification?
Uh, okay, so that's a very deep question, depending on who you're talking to. And maybe I'll start as something that Nikhil was just talking about here. We weren't necessarily looking to build yet just another AI or IDE tool or something like this, right? We're really kind of trying to help people shape software development and their practices for the future. And there's a lot of things in software engineering that have existed since, 40s, 50s, 60s that we're just now seeing to come into play today, right? Like specifications as a term, a lot of people usually have in their head, some sort of formal method that they're talking about, especially when you get deeper in systems. And usually they're talking about certain things like safety properties or liveness properties of your system, right? Is it making progress, moving towards a goal, or are you violating these certain properties? And as you just mentioned, Simon, it's super difficult to tell in code just by looking at it, especially as you trace through a large program or microservices, right? If I want to make sure that I have something like a read after write property of my overall system, you can't just glance at an if statement and determine that in a really complex program. You actually need to lift that up to a higher level of kind of definition for people to see what this means of your system. And then as you're executing the program, you need to make sure that this certain invariant or something is respected throughout the system. So traditionally, the way that this has been done in software engineering is kind of a backwards process, actually. You build these implementations, and as software engineering has become more common domain in the past 20 years or so, lots of people are really good at those low-level implementations of such. But then when it comes to actually, believe it or not, like people that work on their systems actually can't reason about them very well. So you bring then these next-level computer science PhD experts that have knowledge of this esoteric, first-order logic modeling language, whether that's TLA or something like Daphne that AWS uses, or P or something else. You have those very esoteric experts that are then walk backwards from the system, and they build these models to do verification or some sort of validation on the system as well. So what we are trying to do here, to your question of what are specifications, we kind of want to make this approachable for any developer to really have this power, right? And I think that's a super important top level point, because many times when it comes to AI tools, there's an overabundance of talking about, well, now we can make programming available to anybody that didn't know how to code. That's true. We can also make reasoning about systems and new tools available to even those developers that did know how to code before and were kind of the super developers before. Now they have compounding power that they can bring to their practices that they really didn't have before.
Yeah, really interesting actually how it brings it's really going to open it up in terms of it's more of a creator now, right? You don't actually the point of a developer isn't now who can actually write the best code, it's who can create the most, through business logic, essentially being able to communicate better. Will actually become almost the better developer versus their understanding of the underlying implementation. And if you just take it into more of a philosophical kind of like motivation, I know when we talked previously, we were talking about specifications into a much more of a philosophical layer. Talk us a little bit about the philosophical motivation behind.
Yeah, I guess that's the term du jour. Yeah. So let's talk about that a little bit and tie it to your previous question, right? So what are specs kind of, right? You could say specs are this technical artifact, and there's lots of different ways that people build specifications historically. What it re My answer would be a specification is about behavior, talking about the behavior of the system rather than the implementation, right? Um, Now, historically and philosophically, that showed up in lots of different ways. Um, you know, there's been different types of the most common specification known in the industry is something like design by contract. And this is usually where you have this, if you look at the research, this Hoare style logic of saying like, I have this precondition of my function, and these are the mathematical quantifiers it needs to meet, like it can only take an integer within this domain. And then the post condition of that, it must meet this. And then you might define like a termination condition or a loop invariant that has to hold inductively if you're familiar with the terms and so forth. That's the real like sort of like um, program enforcing the contracts of like your functions and so forth. A lot of the newer stuff as well, like if you've ever heard of Lean from Amazon around like specifications, these are more theorem based, which is I would say gives you a bit more fidelity, like even a lower level primitive of something like that, to where you sort of have this. It's based on dependent type theory, where you have a correspondence between types in your programs themselves, how they tie into logic, right? Now, this is important of why I'm going into this around the research and theory of this and how this brings to Kiro, because those are artifacts that people would build with really in those formal languages. And I mentioned specs are about behavior in what you're doing. And so Nikhil will demo here in a minute. Really, like from Kiro's perspective, we try to walk through that at even a higher level so that as we evolve this system, we can meet these different constraints, right? So when you build with Kiro, you're seeing a top level requirements. Well, if you look at this, this is actually something known as a ears syntax. as this easy approach to requirement syntax. And this wasn't just like a clever thing that we figured out with auto formalization to tie a prompt into how you define requirements. It's actually an extension of temporal logic, which is an extension of first order logic. So this gives us a lot of power behind the scenes on being able to control what the model does, how we verify certain parts of the process, how do we build the design, and then how that leads to the implementation itself. And the interesting innovation here is when we tie that to the UX, then you're actually able to bring ground truths to your system, right? So philosophically, what motivated a lot of this was two kind of high level points. And you actually, believe it or not, Simon, kind of touched upon them before. There's a computer science professor, I think he's actually in the UK, believe it or not, Lawrence Tratt, where he talks about two issues with building software. And as I go through these also, we'll be able to talk about how we ran into that inside of Amazon when we were building this. So one is what we usually talk about, the circular specification problem. So this means like you almost need to really build something completely in order to specify it, right? That's how you know what you want it to be. But then you're trying to specify something so that you can say what the implementation is, right? So it goes back and forth. The other is this observer effect when you do this, right? Like the act of actually seeing the software changes not only how we, but also others think the software should act. And that even might be us changing how we look at it over time. So these sort of things are really why I like in Kiro this sort of vibe mode and spec mode as well, right? Like you can build it and vibe it, and now you can specify it, now you can go back and forth. So you get this sort of interplay on how humans act.
Yeah, really, really, really curious, and I think it does. When we think about in software development today, how much even a prototype or something like that helps our understanding of how something should be built, and the way we do iterative programming today through agile methodologies and things like that, we're constantly learning as we go, and it makes complete sense. Like, I'm sure if 10, 15 years ago, or gosh, maybe closer to 25 years ago, pre-agile. If we was to think about writing specs more in a waterfall style, it would make a ton more sense then in comparison to how we build software today. The vibe and the vibe and the spec kind of mode are super cool as well in Kiro. I think maybe we should jump in, and should we jump into demo and actually see this, because I think it'll very much help for our viewers to see this. For those who are viewing on podcast only, on audio only, do check us out on either YouTube, and I believe on Spotify as well. You can see the video through the stream on Spotify, but it's on YouTube in full. It's probably the easiest way to view it. So Nikhil, I think you're going to show us the demo, right?
So let's actually go ahead and look at Kiro and see how this works. So Kiro, what we did is we took it's a fork of CodeOSS, but really what we did that so we could really build an experience that we could fully control from a user experience perspective. So as you see here is I have this tab here for Kiro, which shows you that the core features that we offer. So off the bat, you see there's a specs folder as a structured way to build features. There's hooks, which I'll actually get into a little bit later, but hooks are almost like an enforcer. You can set up hooks to basically watch your code base and make changes if certain files are touched. Steering. So steering what steering does, it allows you to set rules and guide your agent every time you interact with the agent. Whether you're interacting with them via vibe or spec, you can set steering rules. So often what I do is when I'm starting with a existing project, the first thing I do with Kiro is I generate the steering docs, and the steering docs give you essentially they get auto generated, and they give you like a product overview of what they analyze your code base and give you a product overview of what it is. It looks at all the different files and builds an understanding of the project. So as you can see, there's like, here's what the root directory is, here's how it's organized, this is the Next.js app, here's where the data layer is, here's the state management, the type definitions. And there's a tech stack file. So the tech stack here for this application I'm using, it's just a React application with Vite. and it's got some information on what build tooling is installed.
And is this something that you would kind of like expect to perhaps even put into some kind of source control that the rest of
Yep,
the
yep.
team can use, and if you have an organization, you can all kind of like work within a rule set to adhere to.
Absolutely. So right now with steering, we have steering files defined at a repository level. So all these files are actually in your repository. So if I switch to the Explorer view, you'll see there's this .kiro folder here, and essentially everything is in. So the steering files are actually just markdown files, right? So you can check them in, and you can add your own custom markdown file. So what, a good example would be, let's say you have certain rules on how you want your UI to, if you're generating UI for components, your UI needs to follow these requirements, right? It needs to, let's say you need to use tailwind classes, you need to, the styling needs to be certain ways enforced by like the marketing team. So it allows you to, for your team, for you to define a structure of how you operate. A big feature request we've been getting from early customers is, hey, we have actually multiple teams that need to align on, certain rules. How do we define that? And that's something that's also coming soon, and something that we're actively thinking about.
One thing to note as Nikhil goes into the specs too, all these things he's showing are fully composable in the system. And what I mean by that is hooks can trigger at spec workflow stages as you like it for matching file globs and so forth. Similarly, steering can actually mention do X in spec workflow. So like a common thing that a lot of customers do is they're like, well, I actually want to augment my implementation so that it follows TDD, for example. You can create a steering file that will do this with whatever your TDD rules are. Then you go about your spec workflow and it will respect that.
Yeah, I mean, I can quickly even show that here, right? So all I do is I say augment my workflow to ensure that we're following TDD best practices. And then I just hit refine, and Kiro takes that, and now what it's going to do is it's going to say, hey, I'm going to take this, I'm creating this new steering file, and it'll actually like update my lazy prompt to make it a more effective prompt. So as you can see here, so there's an inclusion also. So there are different states for this inclusion. I can set it to manual or always include, right? That so it took my single prompt, and now I have like essentially a new file that to guide the agent.
Awesome. That's super powerful. I love the almost like turning it from a brief into a spec. That's
Yeah, we see spec and steering very much kind of they play together really well. And yeah, so actually let's actually just walk through specs now. So for the application that I have right now, I've got reviews. I added a cart once before. Um, I've got this heart icon here, but I don't actually have any way to add to well, I've got this heart icon here, but that doesn't actually do anything. It doesn't actually work. So I can add something to my favorites. What I will do now is maybe build a new spec about, hey, I'm building this mechanism to add to favorites, and we'll walk through that experience. So what I'm going to do first, I'm going to go ahead and say, hey, I want to create a spec. I'm going to enter an idea here, and I'll say I want to add the ability to favorite um, items in my uh, in my app. So what that's going to do now is it's going to go ahead and create a new favorite system spec. And with that, you can see the agent is creating a requirements.md file. And again, all of this is it's just markdown. One of our tenets for at least our first launch was to build something that had opinions, but make it pretty flexible so users can tailor this to different formats. Again, with steering, if I have some different formats the way I want to generate this, I can do that. But we have sensible defaults.
and so this is the requirements phase. Is that right?
Yep, we're in the requirements phase. So like it took that initial prompt I had, which was kind of really badly defined for a PM, I might say. Uh, but had the ability to favorite items, and then it went ahead and generated a requirements file for me. So let's actually go through the requirements a little bit. So we have an introduction. Each requirement has a user story with acceptance criteria. Now, this is then the acceptance criteria is what we have in years format. Now, this is something that I actually, from my years as a PM, have found really find really useful. So, if you're not, folks are not familiar how Amazon works. Amazon has this process of PRFAQ writing, where we essentially are building a new product. We write a PRFAQ, and then that PRFAQ gets implemented, and you build that out. But often there's a lot of context that the PRFAQ is not able to capture, like the details and the edge cases about how these systems are meant to operate. And the best way I've found to do that working with engineering teams is you break things into user stories and acceptance criteria. So the user stories is almost like the high level definition. So as a customer browsing products, I want to mark items as favorites so that I can find them easily without having to search again. Right? That's the traditional definition of a user story that everyone can understand. Now, when you, if as a PM, you give that user story to an engineering team, there's like a lot of questions around it, right? There's like, uh, how is it meant to work in a scenario? Like, let's just think about this favorites use case, right? So with favorites, when I add something as a favorite, right? Um, if we can a user click and unclick it to unfavorite, right? Is there a count that needs to be displayed of how many favorites I have, right? Like if you actually start building out the feature, there's a lot of details and nuances that go into almost every feature you build as a developer. So over here we've got the first one around marking items, and the acceptance criteria in years format is when a user views a product card, then the system shall display a heart icon, and then there's something around click and not click, and then I want to be able to view all my favorite items in one place. That's the second one. This is a good example of an edge case that when the favorites list is empty, then the system shall display an appropriate empty state. Uh, what you can do here is I can actually um, say like, you know, and I can edit this either here or I can edit this in chat. I can be like, make so for requirement 4, where there's an empty state, I can be like, okay, make sure that this experience has some uh, iconography. All right. So I can do this here, or I can do this in chat. So this is really the way. So as a team, you can iterate on requirements before you move ahead, right? So the third one is I want my favorites to persist across browser sessions. That's another like user story that my simple user story didn't think about. Favorite count indicator.
And when you edited just then, do you prefer the LLM to edit the spec, or how much?
So what I sometimes do is that I personally prefer the LM to edit it, but really like I can if I have a new one, I can just add it here, right? And we have autocomplete as a feature, so it'll start as I type. As you can see, there's something already appeared, so I can start typing and it'll kind of continue. My personal preferences, I do what I just did, but I also sometimes use chat and say, hey, I don't like, for example, let's say I don't really care about a count indicator, so I'll just be like, I don't really care about the count indicator requirement, right? I'm almost vibe coding the requirements right now. Think about it, right? So I just find that the easiest. And there's still a lot of room for improvement here. Like, one of the things that we're thinking of is how do we make these easier to grok? Like, how do you make the acceptance criteria more easier to grok so so users can review them and like understand, to Richard's earlier point, if two requirements have like conflicting kind of information, how does the user how is the user made aware of it so they don't miss it?
Or in a larger team, uh, like multiple people could view what, the three of us, what Nikhil is going through here, even if he had, 10, 15, 20 requirements. Let's say that it's part of a larger system and you want to compare these together to see if there's logical contradictions. That's some of the area that we're looking towards in the future as well, because you really want these in team workflows as you're building them to keep projects moving smoothly.
Yeah. So yeah, as you can see, I think it went ahead and removed that requirement for count. So I'm just gonna say, okay, I think this looks good. I'm gonna go ahead and move to the design phase.
So the requirements is very much about the kind of like the what. So this is defining what we're trying to build. Is the design much more about the kind of like leaning into the how now, about how it's going to start building this into an application? Or is it more about the architecture? How does this work?
Absolutely. It's about how the requirements are the what and the design is the how. So I'm going to go ahead and say, okay, let's move ahead and let's go create the design. Now, what Kiro's going to do is it's actually looking at the existing code base in order to determine what the design needs to be. So as you can see, it's reading a bunch of files, and then it say, okay, I'm going to create now this design markdown file, right? That will get generated again based on the the requirements. Great. So the system went ahead and created a design. Now, the process we've been piloting on Kiro now is that we're heavily dogfooding Kiro internally. Is that we're trying to take the requirements and design. So let's say we're building a new feature, like we have an upcoming like point feature to do. Let's generate the specs for it. Let's generate the requirements. Let's generate the design all within the code base, and then take those as artifacts and sit with the team and decide whether those look good or not. Like, a lot of the time we actually spend as a team, especially when you work in teams, they could be small teams or large teams, is kind of ironing out the details of the design and the requirements. So in this case, what we typically do, it hasn't done it here, but like if you're typically building a feature, we generate like a system diagram. So I can ask it to do it, it'll do it. But in general, it's saying, hey, here's what the architecture is. So we've got, here's state management patterns. Here's the core components and interfaces. So it's going to add like this favorites context type, add to favorites, remove favorites. Uh, Here's the components. There are already these components. We're going to enhance them. Here are new components that are needed. And here's like our data model. Right now we're using a local data model, so it's like adding new interfaces to the data model. uh, Error handling and testing strategies. So it's thinking through, we got to handle errors. Let's think about testing. And here's what our implementation approach is going to look like, right? So I can go ahead and edit these things, um, you know before, like over here I've already kind of I'm down a path where I'm adding a feature to an existing application. Oftentimes what I do is I say, hey, I actually don't want this new, if I don't want a new interface, or if I'm like, hey, you're actually generating something that is, um, that I like. Let's say, for example, I want to focus on unit testing and not integration testing for now. I can go ahead and make those edits. But so this whole process is meant to be the initial start of the process. So where you say, okay, this is where I'm going to start, and this is where I'm going to review with my team. If there are trade-offs that I need to make, I'll kind of add those trade-offs here and make a decision with my team on how I want to proceed.
And what happens when there are conflicts between let's say, your design and your requirements?
So if there are conflicts with your design and requirements here right now, they're basically manually resolved. Typically, your requirements and designs are like, your design is reflected in your requirements. So I can walk through like the process of how you iterate through both, right? So, when I go back to a feature, I can say, hey, I actually want to now add this new requirement to this feature. Let's say the thing that I removed, count, right? I could go back and add count, and then we'll go through the process of updating the design as well to take into account the new requirement.
But let's actually talk about this one for a second. This is a good point. So the process that we do is we use the generated requirements along with other context engines and then some things on the back end inside of the Kiro API that AWS hosts to sort of curry these things as they go forward, right? So using that information from the requirements, build the design, using that, the next phase, Nikhil will show the task list and so forth. Now, a customer could modify their design with something that violated one of the requirements, and it would still go ahead as they go to the next step and build the implementation plan. But we kind of assert, as we were building this over the last year and working with people, that's okay, right? Because the alternative could be, let's say that somebody did something and we went back and verified against the requirements and it violated something, right? That's actually a pretty bad developer experience, right? And this is what happens in the real world. Like sometimes you actually have more domain knowledge than what you can encode in a document, right? And what you see a lot of times with tools is when they try to put these rigid structures in place, you can't do this or go down this path. It actually ends up compounding and having a lot of friction for customers. We got a new visitor in the back there. So so we took the choice that we want to give the customers flexibility here in what they can do rather than restrict them from an action.
So then let's get to the final stage of this process. So as you can see, there's a requirements file we just created. There's a design file, and now what we're going to do is we're going to go ahead and get to a list of tasks. So what the task is, the task list is really the implementation plan. So how do you take the requirements and the design and break it into like discrete items that you as a user can execute against? So this workflow, if I was vibe coding this workflow, right, I would have started with the prompt that I had up top. It would have generated something, and then I would have kept kind of iterating through. But now what I've got is I've essentially got a task.md file, and as you can see here, it's broken it's taken my design and actually broken it into individual implementation tasks. So the first one is create favorites context and hook infrastructure, add the favorites view to the main application routing, create a list component for displaying favorited products. Then it's enhancing individual components, and it's doing things like accessibility tests. So it's really thinking through this very thoroughly. Like I would, if I was vibe coding this, I would probably not think of accessibility, right? Error handling, edge case management.
And how much of these tasks are for the LLM versus the user? I mean, if I was to, is this something that you would really want me to come in and maybe add to, or is this something whereby it adds structure that then allows the LLM to process this in an orderly manner that it can actually do it properly? What's the user interaction with this file?
Yeah, so the user interaction with this file is that I think it's the latter based on what you said. But is that it's providing some structure for how you engage with the LLM, because the structure really helps. I mean, that's been our experience. That's been the experience of a lot of our early testers as well. Is that the structure really helps it implement tasks well and complete and in a complete manner, right? So I'm gonna say this task list again. Because as Richard said, we indexed for flexibility. I can go ahead and edit this task list and remove a bunch of things if I wanted um, to to kind of if I wanted to say, hey, I actually don't want to do this, or I don't want to do I don't want to enhance the product detail component, for example, right? But I'm gonna go ahead and finalize this task list, and now this is kind of some of the unique UI elements we built into this experience. As you can see, there's each of these have a start task button. Very intentionally, one of the first early feedbacks we got from people was like, hey, can you have a play all button? We've been staying away from it because what we've observed with user testing is that as you kind of incrementally build things with editors, you have better understanding as to what's happening, right? So I'm going to go ahead and hit start task here. And what that does is, as you can see, it changes the UI here to say, okay, your task's in progress. And and it's going to go ahead and implement the task. And as a user, what I can do is I I can be on top of what's being done, right? So if I follow the changes being done, what it'll show me is adding all these different. It'll add basically. I think we're building out the underlying infrastructure, if you will, for this favorites context to be done. And I can see all the changes, very easily see all the changes that are being made. So, we're adding some sort of mock storage. There's a test component. So it's starting with like a test file.
I'd love to almost like see an LLM interact with this, whereby it's not necessarily a human clicking the start task, but it's more driven by an LLM, effectively as a judge as well as a orchestrator. That could be super interesting to see how accurately it would almost imitate or simulate a human looking at the output.
Yeah, yeah, absolutely. I think that's a feature that's an interesting feature request that we've seen, where I think what you're saying is that, hey, I've got a bunch of tasks here. Can the LLM can I offload this to an LLM to handle, right? That's what you're maybe a slightly more async workflow. Is that kind of
Yeah, pretty much, pretty much.
so? What it's doing now is that it's actually installing. It's using Jest. It's actually setting up a testing framework as well. I think it's because I added the TDD rule. That's why it's doing this upfront because it was part of my steering. But while this is happening, let me just actually walk through maybe like how this what the state looks like at the end, right? So once a task is completed, as a user, I am able to view um, I'm able to view the actual changes. I'm able to say, okay, here's what. So this was my earlier example, where I was able to view what changes happen, and so I kind of have full context over each of the tasks as to what the LLM did for, or what the agent did rather for the individual task. So as a there's while it's doing things for me, I have kind of full oversight over what's being done.
You also notice the requirements on here. This is an important piece of just the full software development lifecycle. This is the concept of requirements tracing, right? So this is how we document and track the relationships throughout the entire state machine that's executing these things, including as we query the one task to another and process this implementation plan.
So if I were to now go back to, let's say, the requirements, and I were to make a change to one of those requirements, would it look into the design and task list, identify the relation, I guess, between those three, and then say, okay, I only need to actually make updates to the ones that have the references to those requirements that were changed?
Yeah, let's go ahead and do that. Let's say, I want to add like requirement, for counting the favorites, right? Now, the thing is, I don't really need to define this in like the proper format. I just hit refine. So now what this refine button will do is that look at this file and see. I think we have. Oh, I have I have a hook queued. So actually, before I do this, maybe it's a good segue to. I was like, why is this execution queued? Do you see this agent hook thing spinning here?
Ah, I see. Yeah.
So what I have is I have a documentation updater. So hooks are a feature that basically watch your repository for different events. Right now we have file create, file save, file delete, and manual trigger events. So what manual trigger does is that it basically says, okay, you just manually trigger this, and it's almost like an enforcer, right? Like that says, okay, uh, at the end of when a file is touched, do X, right? So in this case, I have if you've created new TypeScript files in the source folder, update the documentation, and I think that's effectively what this hook is doing. Um, yeah, so that's what this hook is meant to do. It's the documentation updater. So it'll go. I have a README file in this repository, and it's gonna go ahead and update that. So I'm able to create a whole variety of hooks, and the way we see customers using hooks is really interesting. So here I have another hook where I've got this component SRP validator. So whenever new React components are added, make sure they're like well defined and like they don't handle multiple concerns. So as a team, I can enforce these practices across my team. So even when we come up with a design, right, that we are actually making the right decisions. Let me just switch back to the design view for my spec. And Richard, I think wanted to add something here.
Yeah, so another piece that's interesting here that I just like to call out is probably my favorite feature here, especially for experienced software engineers, is you might be looking at this and looking at this code snippet or a section of the error handling defined in this doc or something else and being like, I know from my institutional knowledge, this is how I should change this interface, or additionally, I want some other data structure in here or something else. So what we actually built is a context LSP that is integrated in the IID as well as this interface as well. So, for example, if Nikhil were to just in anywhere in the markdown here, just put a pound sign, and you'll see this is actually giving you a context reference, and if he hits enter, it's pointing to a file. So a common thing you could imagine, like this design doc could get really big over time, or you've got common designs that you want to include, sort of like a library import of sorts into multiple designs that you've got over time. So you could actually inject that into here, and then as Kiro goes through these phases, it will respect it as it's building out your implementation plan. Like a great example of this that I use a lot in mine is property-based testing. And property-based testing is a very sophisticated technique that allows you to kind of have a spectrum of correctness in your system, right? It's not full proof based, but it's much more than just unit tests or even implementation or integration tests, I should say, right? And what's pretty cool is IL will create just little markdown files for the specific language that I have. Like if I'm writing in Python, Hypothesis is a great property-based testing library, and I'll say like, this is the structure that I want. And then I can say what the properties are, right? Like these are the properties that I want to hold, which humans are really good at. And then the model will actually do the quantification of that into code. And then when you actually go through running your test, then you get CPUs that execute that with all the fuzzing and so forth. So this is a super powerful feature that encouraged a lot of people as they're building advanced systems to take full advantage of themselves.
And where people want to, they get through to the implementation, and then all of a sudden they think, oh, actually, I'd love to change this thing. Um, let's say and it is a implementation detail. Let's say, of course, when we do something like that, code becomes the source of truth versus the spec, and then how do we regenerate and so forth. How does that cause problems, and what's the best way of kind of avoiding developers touching code?
I would say we don't really see that as a problem if they want to touch code. Now, it is possible, yeah, the specification can drift a little bit from where the code is. Um, I would say that space is going to evolve in the future, and we've got some ideas about how to handle that in a little bit more robust way right now. But I wouldn't discourage engineers from editing code. In fact, if you think about it, we're in a way encouraging them by offering both the spec and the vibe mode. So if you are an expert and you know targeted changes you want to make to your system, by all means, go ahead and vibe those small pieces.
Right, right. So a spec then is if we think about life cycles, how long is the life cycle of a spec? Is it the life cycle of the change versus more than the life cycle of an app if people want to change code?
Yeah, this is a tough question too. I would my common answer is I think about it like comments in code, right? If you put comments in code at that point in time, it's temporal and they will hold. As people and teams edit them over time, they can drift. That is true. So you have to think about it as a similar artifact in your system and build controls around it.
One thing we haven't talked about here on this screen is on the bottom left, Nikhil, MCP servers. Um, what's the best way of kind of like making the most out of MCP servers or other services around from within Kira?
Yeah, so MCP servers work with all the features. So whether you're vibing or you're specking, MCP servers will work. So in this case, I have the fetch MCP server, which actually allows me to do a web search. So if when I'm building a feature, especially even in the design phase, I can be like, hey, can you search the web for what the best practices are regarding like maybe it's a framework or like maybe it's a technology. You can do that. So we have full MCP local MCP support. So you can add any MCP server via like a JSON file that we have here, and you can do that with the chat or you can just update it yourself. And then those MCP servers get invoked by the agent, and the agent can decide whether in spec mode or vibe mode whether the agent needs to be invoked.
So, for example, if we do provide I don't know, a docs creation MCP server, of course the LLM can do docs creation by itself as well. Do you find any challenges between when like the user wants you to use an MCP server, but actually it's trying to do it itself because the LLM has capability to an extent to perform that action? Do you ever see contention between whether it does that?
I mean, I think basically what you're saying is if there's an MCP server that's overlapping with one of your hooks functionality.
Yeah, or even just a basic LLM capability.
Absolutely. I think that you can see that happen, and then I think part of again the way the system is built is that it's flexible enough for you to interrupt when working with agents. Basically, you're working with systems that are not like non-deterministic in nature, right? So you need to make from a UX affordance, you need to make sure that you've got the right level of flexibility so users can interrupt the agent. Like for example, I could have interrupted the agent while it was going and tell it, hey, actually you need to do this instead. So that's all possible with Kiro.
Yeah, and I presume even add it into the task itself to say, da 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 da, I want you to use this service or this tool to create me the documentation for this, or within the hooks. Yeah. Okay, so let's go back into talking about specs just a little bit more. And Richard, I guess the specs that you kind of showed, which realistically is a number of different things. It's the requirements, the design, the tasks, all of that. I guess together is in combination the specification in the Kiro world. In terms of where we are today versus where you started, I suspect you learned a ton of things going through kind of like maybe the private betas, using it internally at AWS. What are some of the key learnings that you took from this journey of learning about specifications?
So a few things. We mentioned, and you kind of you nailed it. Like specifications are kind of the combination of those artifacts in the Kira product, right? But high level, like we talked about, they're about behavior, and really our view on this is, and a learning is, they need to be kind of composable documents with like really functional business use cases, as well as code, pseudocode people can put in there, technical diagrams, behaviors around error handling, behaviors around properties, right? And so some learnings there, like I mentioned when we kicked off this podcast, like there was building the Kiro product and then the research phase also that was kind of parallel and they joined up. Um, let's kind of talk about this and how this went, especially what we haven't mentioned. So I'll start some of this and then hand it over to Nikhil to talk about this. Is like there was a few iterations of SPAC internally that were big failures first. So we proved what wouldn't work actually too, right? So, I mentioned we've got a lot of Amazon has this automated reasoning group that's well kind of known, and we have web pages on it, and they the in the formal methods community dealt with a lot of the same things that in fact, they were inputs into how we built this product itself. And early days of Amazon with these systems, really where specifications were highly used were some of the systems backing IAM and S3 and so forth. And separate from the technology, my biggest learning of talking through those teams and what they were building was there was so much back and forth between people and engineers, right? Like you had people that were experts on the implementation and then experts on modeling the behaviors and so forth. And I remember I saw this one presentation internally, and it was actually like showing the paths between the offices in like a triangle and how the carpet was getting worn. Because what you would do is you say, all right, we define this behavior over here to work like this, and then go talk to the expert on implementing IAM or something. And it's not exactly like that. And you go back and forth in here. And that's really what we're doing here, right? Is allowing you to iterate and go back on that system. And so, without sounding too boring, like a lot of this is, codified institutional knowledge and, SDLC practices. But let's talk about some of the things as we were building this. Like, we could have easily said, like, you know what, we're going to reinvent that space, even though people have been building software and sort of like force certain patterns down people's throats. And so one of them, maybe, and I'll hand this over to Nikhil, that we tried at first, and I touched upon how you could augment your system to do this, is like make every spec go through a TDD flow. That was one thing we tried at first here. So Nikhil, you want to talk about that a little bit?
Yeah, I mean, I maybe talk about that, and then what we did next. So I think the approach was like, hey, let's start with TDD, and TDD is great. Like where you start with tests, and then based off the tests, you generate the code, right? And I think from our early tests, we found that that generally worked pretty well. But then when actually putting that in front of users and customers, it was not typically how they were, like people were working. TDD is great if people follow it, but a lot of customers like are just not not doing that. That was not the logic chain they followed. So what that did is it enforced a lot of rigidity in how people use specs, and the feedback we got from users was that this is not really working for me, right? And then I think the next thing we tried, the next major thing we tried is we said, okay, the experience for generating a spec was, you open a file or a folder and you right click on it and you say new spec, and then we generate like a effectively a specification for what's contained in that folder. But that again was users found that it was interesting. It was like generating like like information about what's there, but that's kind of like what we have with steering, right? So it was like, okay, how do I actually action on this and build something new, right? And I think finally where we landed was we kind of there's all the learnings that Richard's been working on as he's been working, on on this specification based approach with years requirements and designs, and we also saw the field and how power users had changed how they were working with agents, right? There was a lot more planning up front. There was more meticulous thinking up front before doing tasks, and we learned from them. And I think, basically tried to take our learnings that we got that we built in house and apply them with a user experience that's very much front and centered around uh, the development process, which is a requirements design and implementation process, right? And that's where we landed with the current experience. And then, the moment we shipped this, we got a lot of positive signal. And of course, there were tons of issues in the experience when we first built it. And what you're seeing now is probably like 4 iterations in. But the core of this really is around like your requirements, your design, your implementation plan. And I think a lot of the questions you asked around how do I edit this, how do I keep this in sync, how do I review it, are all kind of things that we are very much actively thinking about, not just from a underlying technology or capabilities perspective or science perspective, but also from a user experience perspective, how to make this palatable to users.
Yeah, and from that, when we say users, I guess there are going to be multiple different personas going forward in terms of who has the most opinion on each of these files. And I guess when we think about, I don't know, whether it's tasks versus requirements, I guess we might see two different types of people, maybe more a PM style on the requirements and maybe more an engineer or someone, some kind of like development practitioner who cares more about how things are built. Do you see different owners maybe going forward with these different types of files as part of the spec?
Absolutely, which is why I was saying what we're doing is we're kind of dogfooding this internally, because we have PMs owning like the requirements, engineering owning design. How do we put them in places where they're easy to share? Like a big feature request for we've been hearing is that, hey, we have some requirements in Jira, or we have some requirements in Asana. How do we bring those in and surface them, right? Um, from a and I think from a problem perspective, that's very interesting, right? How do you kind of make the coordination of that better? How do you like short circuit? How do you like save a bunch of upfront time that goes into this requirements and design planning, in a way that makes sense for how teams operate, right? Like we don't expect every team to PMs on every team to be inside a code editor, for example, to do things. So we have to kind of look at how people are doing things in the wild, and enable them in the tools that they're also using.
Absolutely. Let's look a little bit further forward as well before we wrap in terms of where does this space lead? What's the next step? Do you feel for from a spec oriented way? How do you see people in future wanting to use specifications or development with specifications?
Richard, do you want to take that first?
Yeah, I'll start and then hand back to you, Nikhil, on this. Like, so Nikhil's been talking about, a lot of the coordination that, which is really the hard part, right? That you do a lot of with a lot of teams and products and so forth. And there's topics around that he could talk a lot. The one that's the most interesting to me, I mean, there's obviously some other things that we're going to do with giving you more controls about being able to see the ambiguity in the process and contradictions like we talked about before, and also give you more entry points to this workflow and so forth. Those are all technical feature specifics and components of this specification component that we'll do. What I think is the most interesting of where the effect of a tool like this, of what it does is, in some ways it shifts your focus from the post building phase into the code review phase, right? Because agents and models build a lot of different um, code bases and lines of code and so forth. They're getting quite good and refined at these things. No matter what the AI detractors say, they are quite coming along further to really meet some high standards, especially a lot of the benchmarks that we've seen. Um, and you've now got these code bases and requirements, and you have teams and people that need to reason about components of them, right? And that could be reasoning about or reviewing even efficiently in teams the refactoring parts of a program, right? Or it could be about reviewing and reasoning about the new feature parts of the component, or even like the security components, right? Of code, of implications of code changes that are made. So I think that this is going to be a real highlighted area, not just in Kiro, but as the industry as a whole over the next couple of years. That really is untouched right now in sort of the AI and editor space.
Yeah, I mean, I think for me, right, like I think about it from like the problems that we have as teams, right, like look across the SDLC process, right? So like I already kind of talked a little bit about the upfront process on like the back and forth with like finalizing requirements and designs. How do you have multiple, when you have multiple teams working together, like it gets even harder and more complicated, right? How do we kind of improve that process, right? And then going forward, uh, past the review, once something is out in the wild and there are issues, how do we bring those issues back to the actual development team, right? So we're really looking at this from a whole life cycle perspective, and there are core things that are not going to change, not going to be impacted by by AI in terms of the problems you have, right? Like you ship software, there'll be problems with it. How do you get those problems? How do you fix those problems? When you build software, there's ambiguous requirements or design. How do you solve? How do you make that easier? So that's how we're looking at this space, and problem solving in this space.
Awesome. And where are we with the build right now? Looks like we've just completed. I think this was this section 4.
Yeah, we've completed a bunch of tasks. I've been going at it while we do things. As you like, one of the things that you see that's happening is that it's actually being very methodical with generating tests. So it generating updates. So like like I just executed a card for this enhanced product card component with favorite functionality. So it's actually like making sure the tests are set up right. And so let's actually see what it's done now. So I've got it's added like it's added a favorite here already, so I can favorite things. Let's see if they. I don't know if this is. Yeah, yeah, they're actually showing up as favorites as well.
And remember, this one, Nikhil had that steering file to use TDD first, so it actually augmented his flow to do some of these up front rather than later.
Exactly, and I picked a relatively easy feature. A lot of times, people use these AI demos to say, "Hey, build me a game or build me something," that are very much greenfield, right? But like the reason why I picked an easy feature, like adding favorites, is not because is to show that there's actually a lot that goes into building favorites. It's not just like a simple thing that you can add to your application. You have to think that having tests, making sure things are accessible, making sure like the number of scenarios that were covered here are things that I would have not thought about doing.
Yeah, and the nice thing is it's the tests that are added, and I'm sure the tests would have equally been added if we didn't do the TDD piece, but probably after towards the end of the tasks. It's not the thing that we miss with vibe coding is the ability to actually validate and truly say yes, this is all working. I haven't regressed other things, and the nice flow about this is tests are being built by default. It's coming as part of the package, and it allows us to validate every step of what we're doing through the tasks.
Yeah, absolutely. And like the product of that the hook was that the I had to update like the README file. So a lot of developers like the README file to stay updated. So as you can see, it added like the favorites to the favorites to the actual experience, and it'll keep this README up to date. The hooks experience is one of my favorite things because you can really like do the same thing. You can language localization is also a good one. Like you add a new feature and you want to make sure that your strings are in different, in different languages. You can just have a hook for that. So we're really seeing customers get creative with the types of hooks they're creating.
Yeah, and you just avoid that debt that will typically follow you around when you don't do these things as well.
Yeah, absolutely.
Amazing. This has been a great demo. It's been really really great fun chatting with you both, and congratulations as well on all the success that Kiro's had. From what I saw on Twitter, I think it's in a waiting list right now just because it's had such an impressive number of downloads from people wanting to try it out. What advice would you give to people who want to play with it today?
Yeah, we are so grateful to everyone trying to get on. We've got thousands of users, and we were trying to optimize the experience for the users who have access. That's why we added the wait list, and we're working very diligently to get people off the wait list. And you should be hearing something from us very soon.
Awesome. And if you're interested, Kiro.dev, I believe, right?
Yep, Kiro.dev.
Kiro.dev, and you can join the waitlist there. Wonderful. Nikhil and Richard, it's been an absolute pleasure. Very, very insightful. Thank you very, very much for sharing your knowledge as well as Kiro and the demo. For those watching online, for those listening only onto the podcast, do check out the YouTube video because there's a ton of value in the demo that was shown today. Really appreciate you both joining. Thanks very much.
Thanks, Simon.
Thank you.
And thanks very much for listening and tune into the next episode.